Welcome, trigonometry friends. Today we're doing another variation on Johnson Jackson's Pythagorean Theorem, c squared equals a squared plus b squared. It is based on the J&J fourth proof in an article called 5 or 10 Proofs. It was published in 2024. And go ahead and take a look at this. I'll make another zoom of this. Okay, and so the preliminaries that we need to do, of course, is, well, here's our basic triangle setup. You've got A, B, and C. And so, I gotta fix this, yes. So you've got A, B, and C, and it's symmetrical. So you got angle beta, beta, here's alpha, alpha, and so forth. Here's 90 degrees. And what we do this time is we draw a perpendicular to CB, and that forms another triangle which is 2 alpha and beta minus alpha and 90 degrees. And this is a kind of a characteristics of the Johnson Jackson triangle. It's 2 alpha and beta minus alpha and the 90 degrees. And so here's our preliminaries. We got sine alpha as A over C. And that's the same as cosine beta, of course. And cosine alpha is B over C. And that's the same as sine beta. And then we have sine of 2 alpha. That's from a double angle formula. It's 2 sine alpha cosine alpha, and in ratio form it comes out as 2ab over c squared. And the other one is sine beta minus alpha, which is sine beta cosine alpha minus cosine beta sine alpha in ratio form. It comes out as b squared minus a squared over c squared. Okay, so these are the preliminaries that we have done. And now let's go on. So we need to find out what AD is, this distance. And that's simply 2a times cosine alpha. 2a cosine alpha. Okay, so here's angle alpha. And so the cosine would be adjacent, so that's why it's 2a cosine alpha. And so it's in ratio form 2ab over c, right? 2a and cosine alpha is b over c. And BD, that's this distance here, well, that's 2a cosine beta. So 2a cosine beta. And so it's 2a times a over c, which is your cosine beta. So it's 2a squared over c. And then once we have BD, we need to figure out what CD is. And that's just c minus 2a squared over c. And you've got to normalize the denominator, so it comes out to be c squared minus 2a squared over c. That's this distance CD. And now here's the famous thing that Johnson Jackson do. They do the law of sine. So sine of 2 alpha is to AD as sine of beta minus alpha is to CD. And now just plug these values in. We got sine of 2 alpha is 2ab over c squared. AD is 2ab over c. Sine of beta minus alpha is b squared minus a squared over c squared. And then CD is c squared minus 2a squared over c. Looks fairly messy, but I'll let you simplify it, do some algebra here. It's nothing magic. Just do some cancellations. And you get 1 equals b squared minus a squared over c squared minus 2a squared. Simplify it further, you get c squared equals 2a squared. Excuse me, c squared minus 2a squared equals b squared minus a squared. And now, fix it, throw this a squared over, you get c squared equals a squared plus b squared. So that's the famous Pythagorean theorem. And so, this is the variation on Johnson Jackson, and it uses their famous triangle of beta minus alpha and 2 alpha, and the law of sines. That's kind of a characteristics of their. And if you look at their fourth proof in that article called 5 or 10 Proofs of the Pythagorean Theorem, very similar thinking, similar structures. This is a slightly different take on it, slightly different variation. So that's what it is. So thank you.